Okay, we're back in the engine assembly room. We have our block here. We have our stroker crank here. Shane will measure the main bearing journal diameter with a micrometer, and he'll lock that figure up. What's important here, you can see he's measuring all the journals. Now technically, you want them to be as close as practicable to one another. You don't want them to all vary a thou or two because that's not much good. Once he's taken that measurement, he's now set up his dial bore gauge and he's measuring the main bearing tunnel with the bearings torqued in place inside the main cap. Now, it's pretty obvious what he's doing. He takes a measurement of the bore, he takes a measurement of the crank journal. The difference between those two measurements is the vertical bearing oil clearance. Instead of using something as imprecise as plastic gauge, snap gauges or whatever, this is the way to do it. A micrometer and an accurate dial bore gauge. And the difference between the two, he's checking the difference between the two. He's locked the main bearing size on the gauge. What is it?
2.2 thou.
2.2 thou, which is fine. We're using an LS aluminium block, and technically you'd normally think, oh, that main bearing clearance is way too tight. But on an LS motor you need a tighter main bearing clearance simply because the aluminium block expands at a much greater rate. So that the clearance will open up considerably more. So that's fine. Shane is doing the same thing with the connecting rod, one of the con rods. He's locked a bearing in the con rod, he's torqued the rod, and he's measuring the bore. He'll take that value and compare it to the rod journal diameter. And the difference will be whatever it is. I mean, on an engine like this, you need it to be somewhere between 2 and 2.5 thou. What do we got? This is very important. It's also very simple. If you don't have these tools, by the way, get your machine shop to do this for you in front of you. They're more than capable of doing it. If they've machined the components, the clearances can be verified before you put it together and before you have to worry. If you're putting it together in your shed, at least you know it's right. Pay them a bit extra to do it for you.
It's got 2.4.
2.4, which is perfect. You know, anywhere, we need over 2 thou for something like this. Particularly, this is going to be a boost engine. And that's the other thing about clearances. They'll vary on applications. You'll sometimes run a bit more clearance for a certain type of engine. We're being very general here, but what we have here is what we want and what we need. The next step here, we've got Shane about to measure the ring end gaps. Now he's already ground these, and you can do it in a vise with a file as long as you deburr the edges afterwards. You can see what he's doing. He's sitting the piston onto the actual ring. He's left a ring there so the piston doesn't fall. You know, we've got a specific little tool that we use, but using the piston is excellent the way he's done it. He's measuring the gap. The top ring gap we're using for this particular engine is 25 thou or a bit more. That's a bit high, but it's a boost engine. They need more gap because there's a lot more heat generated with a boost engine. So the top ring will expand to a far greater degree. The second ring end gap would probably be around 20. If it was a normally aspirated engine, we would end up around 22 thou, a little bit less. There's nothing wrong with going a little more rather than too little, because if you have too little, what happens is the rings will butt. The rings will butt at the parting line and they can break. So a little more is better than too little. Shane's about to drop the crank in. He's put some assembly grease on the main bearings that are in place. And a strong recommendation to all of you who are wimps like me, who aren't as strong as they used to be, put some plastic tube on the inner bolts here, or the inner studs if you're using a stud kit, because it's very easy to nick the crank journal. And as I said, you'd be moving around and not a smart move to nick the crank. So put some small plastic tube on to prevent that happening. Shane's installing the main caps, and they're also lubricated. We'll come back and show you end float checking, the thrust end float. The thrust on these is in the centre main, and he'll tension up the main studs. Shane's going to check the thrust end float, the crankshaft end float in the thrust bearing. It's a centre main. All the main bearing caps are not fully torqued. They're pulled down fairly firm, and he's nipping it up when he's got the crank thrust one direction, and then he will read the dial indicator. He'll push it both directions, as you'll see with the screwdriver on the web. And we're averaging, I suppose, around 4 thou. And the factory tolerance for this engine is about, I think it's 1.5 to 7 thou. So we're looking good. It's very important to verify this, because if you have it too tight, you'll burn that bearing up very easily, particularly with a manual transmission car with a heavy clutch. You need some thrust clearance there. It's very important. If you need more clearance, it's a pretty easy deal to remove the centre main and rub the face of the bearing on some wet and dry with some solvent, just to reduce the dimension. You don't have to grind the crank, just modify it with the bearing itself. We verified that. Now he'll torque the mains up. All right, Shane's pulling the studs down. He uses 60 pounds, foot-pounds on the inner, 50 pounds on the outer bolt, and on the small side fasteners he uses 20. What's also important, and it's not easy to show it to you visually, but when you sit a cap in the register on these engines, and that applies to just about any engine block, but it's even more relevant on an LS type engine, is position the cap as close as you can to the centre of the register. You know, they can move slightly sideways and they float a little bit on the studs or the bolts. So position it on the registers, and you can generally do it by putting your hand in there and rubbing it along the register, just below the register. But other than that, it's really not a big deal. He's going over those fasteners and just verifying the torque numbers. And whichever ones you do first is irrelevant. You can do them in whatever order you like, except obviously your centre ones first. Then your outers, and then your horizontal, your small little bolts. You can also see he's doing it in stages. He's not pulling the full torque value of 50 pounds in one hit. He'll come down in, say, to 20 pounds, to 35, and then to the final 50. And it's not critical to see the number, to move the torque wrench to 30, 40, 50. You know, if you're experienced, you sort of know. But if you're not experienced and you're concerned, do it in steps of, say, 10 or 12 pounds or 15 pounds each. And that's it. We've just installed the rings. That's pretty simple. On the thrust face, you can see the oil ring gap is here. I mean, there's a lot of different ways to do this, but you know, we sort of tend to do it this way. They need to be staggered from the compression rings. So we turn the piston around and we have, let's say, the top ring adjacent to the pin here. We'll go around 180 and we've got our second ring here. And that's it. Now what's important, please do yourself a favour and buy yourself a fixed style ring compressor like this, so that when you're fitting the piston assembly into the engine, you're not going to break the rings. And that's very important. I'll give it to Shane and he'll slam it into the block. Okay, Shane has the fixed ring compressor. He's got the bearing in place. He's oiled the skirts and all the piston rings on the piston. He sits the ring compressor evenly on top of the deck. He lines up with his hand below the conrod so it doesn't belt into the crank, which tends to happen sometimes. And as you can see with a fixed ring compressor, you've got no chance of breaking a ring. As he pushes down, he guides the bottom of the rod over the crank journal. If you're using a conrod that has a bolt poking out, we don't have that situation here because you know, we're using an H-beam rod with a cap screw fastener. But if you have a rod that's gone into the engine with a bolt, a rod bolt and a nut hanging out, put a little bit of plastic tubing over it so you don't nick the crank journal. In this case it's not an issue, but with a regular bolt nut type rod, which is predominantly your I-beams, that's something you need to do. Now Shane's installed the first rod in number 1 cylinder and then he's gone to the other bank, which is number 2. Make sure you always do this. You must put both rods on the journal. This is not torqued up, it's just hand tight virtually. And he'll put the cap for number 2. It's lubricated, it's in the right orientation. Don't ever tension any rod bolts without having both conrods attached to the specific journal they're designed to be on. Because when you tension a rod here, you can very easily twist a conrod if the other rod isn't in place. In actual fact, the other rod acts like a bit of a vice to stop it from twisting and moving. What he's doing now is checking the rod side clearance. You must have clearance between the two, and that's very important. And as you can see, with the feeler gauge in place, he's torquing the bolts up. You're an ARP 7/16 fastener, and they need around 65 foot-pounds. Once again, he's doing them in stages. You notice he moved so that the thrust or the load on that rod can't twist. He's taken up the slack there. What size feeler gauge is that?
That's a 20.
That's a 20. Well, that's a good side clearance for these. Very important to have side clearance. You can see he's got even movement and everything feels good and they're tensioned up and we're ready to receive the rest of the piston rod assemblies. Before we do that, we're not going to worry about that at this stage. We're going to look at the camshaft and camshaft timing. That's all there is. That's all there is to attaching the bottom timing gear. You notice we use a single row timing set, even on a high performance engine. And I know many engine builders are going to cringe at the idea, but you know what? I don't really care, and I'll explain later. Shane's brought the piston up to top dead centre. He's already got the cam in. I don't think we need to teach you how to put a cam in an engine. You can always get our cam installation video. That'll show you exactly how to do it. But it's pretty straightforward. The LS motor has got plain bearings and it's got a thrust plate. Very simple, just bolt it on to factory specs. The timing set he has here, it's like a traditional Chev small block. You're looking to line it up dot to dot. Dot to dot meaning the dot here and the dot here. And we'll get a little bit of a close-up for you in a minute. In the meantime, he'll just fasten the 3 bolts, factory bolts, which fasten the top timing gear to the camshaft. This is an LS1, so you can see it's got a single cutout for the cam sensor. The later ones have got interrupted type cutouts. It's very important that you put the right one, otherwise it won't run at all, or it'll run rather badly, and it may never even start. It's not a big deal. Line up dot at the bottom, line up dot at the top. They need to be lined up when you're installing. And that doesn't apply to every engine family. A Holden V8's different. Once again, you can see in detail how to do a Holden V8 on our cam installation DVD. But on the LS1 and many other engine families like your Ford V8s, your Chevy traditional small block V8s, etc., it's dot to dot. And you always check it from that point. You'll notice this is not an adjustable timing set. We're pretty confident that the dial-in will be spot on because we grind the cams relative to the pin, the locator pin, to achieve that without, you know, using adjustable timing gears. We try to do that with everything. It's not always, it doesn't always work out when people have gear drives or other stupid things like that. That's another thing. We don't recommend the use of gear drives, but we'll show you how to verify this camshaft using the lifted top dead center method we spoke about earlier when we showed you how we measured the cam. We just want to illustrate here a couple of the tools we use for checking lifted top dead center. We install a flat lifter on a flat tappet cam. We install this type of end on our checking indicator to simulate a roller cam. This is very important because otherwise you won't get the correct figure. Flat tappet cam has got a different rate of lift and you won't get the right answer. When you're checking a roller, you need a roller lifter on the cam to check for the correct lifted top dead center. When you're fitting a flat tappet cam, always use a flat lifter for checking. That's very important. This is a roller cam, the LS motor, so we'll be using this fixture right now. Shane's attached a dial indicator above the piston so that he can verify when the piston is at top dead center. He's rotating the engine in the normal direction of rotation. We have our dial indicator sitting above number 1 intake lobe. As it comes up, piston is rising, you'll notice the lobe is lifting. In other words, it's opening the valve. He's right on top dead center now. We're on the 0 and we've got 47 or 48 thou. The specification for this cam is just on 50 thou if you want a 111 intake centerline. That means it's advanced 3 degrees. In this position, it's advanced probably 2.5. You know what that means? We can put the timing case on, it's spot on. What I need you to know, 3 thou here is barely 1 degree. So it's near enough. Don't adjust it, it'll work fantastic where it is. You have a tolerance. I suppose it varies with different types of cams, but if you've got if you were at 45 thou, I still wouldn't touch it because that's only 1.5 further back. You're still advanced. Instead of being 3.5 advanced, you know, you're 1.5 advanced. Leave it alone. This cam works best on anywhere from 110 to 112 intake centerline, which means anywhere from 45 to a little over 50 thou. There is a range, a tolerance, which will be fine. Now, isn't that an easy way to check a cam? See, we don't need a degree wheel. I hate those things. They confuse my stupid left-handed brain. We're done. I've had Shane bolt on just a dummy head onto this short block. You know, we've installed the crank and we've installed the conrod piston assemblies, but I want to show you how to set the lifter preload, or at least check it. Now this is a 6-litre head, it's a big port head, it's got the wrong valves. We shouldn't really have it on this LS1 small bore short, but for illustration purposes you'll see Shane's got the push rod in place, the lifter in place, he's tightening down with a ratchet till he's got 0 movement. That means he's at 0 lash. It's firmed up, and then he'll tighten it further, and if you noticed, he got a little over 3/4 of a turn. When he did that, he was actually preloading this lifter cup. He was pressing it in. That's what we're looking for. We need a certain amount of lifter preload. Ideally, a full turn, 3/4 minimum. We've got that. If you don't have that, for example, if you can only get 1/4 of a turn, you need to change push rod length. If you're getting too much, same thing, a longer push rod. At the end of the day, you have to get this geometry right, and you have to preload this lifter. And if you hear someone tell you, oh, you know, we're running only 1/4 of a turn or something because they want more RPM, tell them you don't want to do that. You want 3/4 to a full turn. And that's how you do it. We're just illustrating the installation of the rear cover plate, incorporating the rear main seal on an LS Chevy V8. You'll fasten these 2 bolts just firmly, back them off. You'll center the plate visually right over the surfaces here. Slowly nip them up. That's basically it. Do up the rest of the fasteners. That seal isn't going to leak. Obviously have some oil on the seal surface, and we're done. Now we're at the front of our LS engine. Timing case. Notice there are no line-up dowels. There's a special factory tool you can use to line this up and then tighten your bolts up. But you can also use your harmonic balancer. Slip it on and pull it down, and then maneuver the seal central over the shaft. It's not really very difficult. The factory tool is very nice, but it's not essential. You really want the timing case in a position where it's nice and concentric.